This is a science fiction story about Dr. Cassandra Vale, a physicist who discovers how to make dark matter interact with ordinary matter. Initially funded by a weapons contractor, her breakthrough reveals that dark matter can be weaponized with devastating potential, far exceeding nuclear weapons. Despite the moral dilemma, she conducts the first successful experiment, proving the technology works. The discovery triggers a global arms race and international tensions as nations scramble to develop dark matter weapons. To prevent catastrophic misuse, Cassandra eventually publishes all her research publicly and becomes the first director of an international regulatory agency. The story concludes with humanity learning to harness dark matter for both beneficial purposes like clean energy and space travel, as well as confronting the ongoing threat of its weapons applications. Pushing her hand against the cold metal of the containment chamber, Dr. Cassandra Vale could feel the vibration beneath it all. She knew that everything was about to change. She had been chasing shadows, literally, for 3 years. 80% of the universe was dark matter, and it was proving peskily, frustratingly invisible. It would interact with normal matter through nothing but gravity. Until today, her team rushed around the lab in a jittery fervor, not wanting to miss what might either be the greatest discovery in science or the dumbest mistake in the history of humankind. Her lead engineer, Marcus Chen, was running one last set of diagnostics on the particle accelerator they had hacked beyond recognition. Sarah Rodriguez watched over the quantum field generators that would make the conditions they needed for their experiment. And Dr. James Whitmore, the weapons contractor who had been bankrolling their research, watched from an observation window with hungry eyes. Cassandra had found the theoretical basis of it herself 2 years ago on a sabbatical at CERN, when she was investigating collisions in data collected by the Large Hadron Collider. She spotted mysterious energy features that showed up after high-energy particle impacts. The signatures were short, on the scale of just nanoseconds, but they hinted at something extraordinary under the most extreme conditions. Dark matter might be pushed in to interact with ordinary matter in ways that broke all the rules they thought they knew about physics. The implications were staggering. Were it possible to cause dark matter to interact with normal matter, it could potentially be exploited as an energy source. The universe was awash in the stuff. Every cubic centimeter of space held thousands of dark matter particles. If they could harness just a small portion of that power, they could transform everything from power generation to space travel. But Whitmore had different ideas. He was speaking on behalf of a group of defense contractors who recognized the military implications right away. A weapon that could access the dark matter field would truly be invincible. It would dwarf even nuclear weapons. And he had supplied the money that had financed Cassandra's research. The moral burden of her discovery had kept Cassandra awake for months. She'd gone into physics to learn about the universe, not to invent new mechanisms for destroying it. But without Whitmore's financing, her research would have remained stalled in committee, choked by the layers of bureaucracy and skepticism that govern antiviral drug research. It was, she told herself, and the knowledge was neutral. It was how human beings used it that made it good or evil. Marcus sat up from his console, his face a pale glow beneath the fluorescent. All systems are green, Cassandra. Magnetic fields are holding, and quantum resonator is in standard state. Sarah nodded from her station. The dark matter detection array is alive. We're measuring an average of approximately 4,000 dark matter particles, cubic cm. That's consistent with theoretical predictions. Cassandra took a deep breath. It was a deceptively simple experiment in conception, and a fiendishly complex one in execution. They would form a small area of incredibly intense gravity with their altered PA. Then dark matter particles would clump more densely than they normally do. The researchers would then zap this collection with a precisely calibrated burst of electromagnetic energy meant to disrupt the enigmatic force that kept dark matter from interacting with regular matter. If they were right, they could look forward to a short, brilliant cascade reaction as dark matter particles exploded into view and into communication with ordinary matter. The energy would be confined within their magnetic field generators, and they could observe the event safely. If they made a miscalculation, the energy release could have opened a rift in space-time. Starting up the gravitational stress field, Marcus said, the colliders were activated and the magnetic coils began to form a bubble of folded space. Dark matter particles, normally spread evenly through the universe, started to build up in the target area, growing like iron filings racing toward a magnet. Sarah's readings spiked. Dark matter density is increasing. We are now at 12,000 particles per cubic centimeter and counting. Cassandra felt her heart racing. They were entering utterly uncharted territory. No one had ever tried to manipulate dark matter directly with a human device. The theories said it would work. The scientists behind the project were well qualified to test the theories. But theories had let astronomers down before. In graduate school, she'd learned the history of nuclear physics and how the scientists of the 1930s had thought it was impossible to make atomic weapons right up until they didn't. 28,000 particles per cubic centimeter dark matter and rising, Sarah said. That's 7 times normal background levels. Whitmore leaned forward on the observation deck. How much energy are we talking about, Dr. Vale? Cassandra did not lift her head from her instruments. If our models are right, every dark matter particle has about the same amount of rest mass energy as a proton. But because dark matter does not interact electromagnetically, that energy is typically hidden. We're trying to change that. But how much energy? Whitmore pressed. Marcus answered grimly. Under these conditions, the minimum energy release is equivalent to a detonation of a 510 nuclear device. If every particle of the local dark matter halo were to become active. The observation deck fell silent. Cassandra had been adamant about complete transparency with respect to the risks, but hearing the hard numbers voiced aloud made the scale of what they were attempting to accomplish even starker. That's why we have the containment field, she said, attempting to sound more certain than she was. The magnetic bottle will keep the reaction and the energy where it is safe. 35,000 particles per cubic centimeter for dark matter, Sarah yelled. We're approaching maximum theoretical concentration. Cassandra read the readouts on her main console. Everything was going according to plan. Yet she couldn't banish the thought that they were about to step over an edge they couldn't step back from. If people discovered how to turn dark matter into a weapon, there was no turning back. The knowledge would get out, doomed to leak despite any containment effort. Within a generation, all major powers would possess dark matter weapons, but the researcher in her was intrigued. Dark matter has existed as long as the known universe. It was discovered in the 1970s, when its gravitational effects on the rotation of galaxies were observed. For 50 such years, it had been a mystery of the racing cosmos. And if they could just figure out why dark matter does what it does, it would mark the biggest breakthrough in physics since Einstein's theory of relativity. Gravitational stress field maximum, Marcus announced. Total dark matter density is stabilizing at 38,000 particles per cubic centimeter. EMP generator charged and ready, Sarah chimed in. We'll go for phase 2. The button to enable it was there, but Cassandra didn't press it. Once she tapped it, nothing would halt the cascade. Their shell would hold, or more likely, they would accidentally unleash a local apocalypse. She thought about her daughter, Rebecca, who was majoring in environmental science at Stanford. Rebecca is only in her field to help heal the Earth, not to figure out how to destroy it. What would she think of her mother's work? Would she see the purely scientific curiosity behind it, or would she see the destruction painstakingly designed for it? Dr. Vale, do not touch them, said Marcus in a hushed accent. Gravitational stress field starting to get erratic. We need to proceed or abort. Cassandra shut her eyes for a second, imagining all of the researchers who would have confronted. Moments of truth like this one. Oppenheimer, a Trinity. Fermi and the original nuclear reactor. That was a time when pure science swiped scarifyingly at the prospect of calamity. Engaging electromagnetic pulse, she said, and hit the button. Pulse was precisely 3 nanoseconds long. For that split second, the electromagnetic field in the targeted region oscillated at a frequency determined to shatter the quantum mechanical properties that allowed dark matter to remain universe's unseen underbelly, said a statement. From the Weizmann Institute, its impact was swift and severe. The air in the containment chamber filled with intense blue light as 38,000 particles of dark matter lit up and became active. The cascade reaction unfolded exactly as Watzikowski predicted. One by one, each particle released its stored energy in a fit of exotic radiation. The magnetic envelope groaned under the immense power surge flooding, the coils burning white-hot dot, but the field held. The energy was trapped, directed and safely released through the coolers. For 15 seconds, their lab contained a denser charge of energy than mankind had ever managed to muster before. Then, gradually, the reaction subsided. Containment field. Is holding steady, Marcus said, his voice trembling from the excitement. All systems are nominal. The energy output matches the theoretical predictions, Sarah added. We did it. We actually did it. Cassandra watched the data scroll down her screens. They had showed that dark matter was weaponizable. The implications were staggering. A weapon that drew on the dark matter field would have nearly limitless power. Dark matter, unlike nuclear weapons, also was everywhere. Every square inch of space was full of the seething raw potential for destruction. Whitmore was already on his phone, no doubt recounting his story to his superiors from the observation deck. The weapon's implications were clear and terrifying. It would not even necessarily stop at destroying a city, but could potentially crack the Earth's crust or destabilize its magnetic field. But there were other implications as well. If dark matter could be interactive, it could be an energy source. The energy density was millions of times greater than chemical fuels and thousands of times greater than nuclear fuel. It could take us far out into interstellar space, powering our spacecraft, or supply clean energy to an entire civilization. Cassandra's laboratory was the most closely guarded site in the world during the subsequent weeks. Government officials and military contractors and foreign observers swept in like vultures. The discovery was too significant to keep quiet, but too perilous to provide to anyone without restrictions. Cassandra was in the center of discussions that would determine the future of mankind. Some argued that the technology should be completely quashed, that it was too risky. Others argued that the knowledge would inevitably be rediscovered by somebody else, possibly someone less scrupulous about its application. It took centuries for the various nations of the world to come up with methods of controlling dark matter. Technology, dark matter weapons, may be difficult to build, but they won't require their own industry of rare facilities or materials beyond the ability of just a few people to access them. The technology was scalable in a manner that rendered traditional arms control agreements outdated. 6 months after the breakthrough, Cassandra's daughter, Dr. Rebecca Chen, saw the lab. She had temporarily left Stanford to consult with foreign environmental groups about the impact of dark matter technology. "Mum, do you know what you've done?" "What's rattling?" Rebecca asked as they wandered down the hallways of the Dalton Medical Facility. "You have given us the power to rip fucking holes in the motherfucking space-time continuum. Every terrorist group, every rogue state, every unstable regime is going to purchase this technology." Cassandra nodded sadly. "I know, but Rebecca, listen. This had to happen. The physics is too basic, the implication too transparent. If this were not our own breakthrough, someone else would make it before the decade ended. At the very least, this way, we can attempt to steer how it is developed and how it is used." They came to a halt in front of the containment chamber from which the original experiment had been done. The chamber had been rigged with substantially more powerful safety protocols, but the underlying principle was the same: controlled tweaking of the quantum properties of dark matter so that it could interact with normal matter. "You can't put the genie back in the bottle," Cassandra said. "The question now is whether we can teach it to grant wishes, instead of just destroying everything it touches." Rebecca's eyes had been scanning all of the complicated instruments and readouts. "There's something else, isn't there? Something you're not telling the public." Cassandra glanced around nervously, then escorted her daughter into a secure conference room. "I'm going to tell you something, and this is as high level as it gets. The first experiments were only the start. We found that there can be a very large enhancement for dark matter interaction. What we've done in the lab are drops in the bucket compared to what can be achieved." She brought up a hologram of their most recent theoretical models. "If we could generate a strong enough gravitational stress field and do so at the right frequency, then the amount of DM that could be converted in a region of space that is large enough, say, to detect here on Earth could be substantial. We're talking about populations of stars exploding, and those superordinate systems are in the forefront of it." Rebecca looked on in horror at the models. "Mom, that's not a weapon. That's a reality-altering force. You're talking about the ability to shape the underlying structure of the entire universe. That's why we have it classified," Cassandra said. "But the theory is right, and if we can solve it, so can others. The Chinese have already begun their own research program on dark matter. The Russians are said to have had some success in detecting dark matter. There are plenty of people who have had the same idea, and it won't be long before somebody puts 2 and 2 together." It weighed on Cassandra in the months to come. What had been touted as a technology that could unlock the secrets of the universe turned out to bring forth the capability of hitherto unimaginable destruction. She witnessed as nations launched a race for arms like nothing in human history, with each working to engineer its own dark matter weapons before anyone else and underground. Test in Nevada of the first dark matter bomb occurred 18 months after her first breakthrough. The explosion was contained, but the energy release could be seen. From space, a column of strange radiation that stabbed through the upper atmosphere and bled away into the void of deep space. International tensions escalated dramatically. United Nations tried to broker a non-proliferation treaty for dark matter, but the tech was too valuable and too dangerous for any one nation to accept real restrictions. whereas nuclear weapons were limited by the fact that you could only manufacture them in expensive, large, and easy-to-spot facilities. Dark matter weapons would be in theory producible from tiny nuclear-scale facilities through a combination of secret black budget weapons development methods. Environmentalists received death threats from environmentalists accusing her of having produced the ultimate weapon of mass destruction. She also got job offers from foreign governments that wanted to hire her expertise. She knew the moral grayness of her situation was off the charts, diving into collaborations with international humanitarian organizations. She began developing beneficial applications for the dark matter technology. If the potential for harm could not be contained, then maybe it could be squared with constructive uses. Dark matter in physics. A dark matter power generator might yield clean power for Earth's use. Stellar systems could be traveled between if dark matter propulsion was harnessed. Control of dark matter might one day be employed to clean up environmental damage, or even to terraform other planets. But weapons applications continued to be the dominant focus of most research. The military gains were too great to heed that risk. No other enemy would be able to harm a country with sophisticated dark matter arms. The technology offered to upend the geopolitical world. 2 years after the discovery, Cassandra took a step that would shape the future of her career. She published a paper that extensively described not just the weapon's potential of dark matter technology, she also explored its peaceful uses. The paper was published simultaneously in every significant scientific journal and made available on the internet. The response was swift and explosive. She was charged with treason by government officials. Military contractors threatened lawsuits. International observers hailed her for democratizing access to the technology. The scientific community was split between those who hailed her transparency and those who asserted she had damned humanity. Why? Rebecca said during one of their regular video chats, "Why did you release everything?" Cassandra looked tired. The pressure of the last 2 years had visibly aged her, because everyone lying made everything worse. It was destabilizing when few countries possessed the technology. Now that everyone has seen the complete range of what's possible, perhaps we can all work together to build it appropriate. The risk proved rewarding, at least not in the way Cassandra had anticipated. Rather than encouraging a race, the release of the entire theoretical scheme initiated a qualitatively new level of international collaboration. Its very scope, the knowledge that misuse could endanger the entire planet, pushed nations to cooperate. International Dark Matter Regulatory Agency was created in under 6 months. Unlike previous arms control bodies, this one had real teeth. That is, the capacity to monitor dark matter research worldwide and take action if necessary. The agency was paid for by all of the great powers of the world and was manned by scientists. From every country, Cassandra became its first director, a role that placed her at the epicenter of mankind's struggle to will its most dangerous technology. She is yelled at by men who call her arrogant and incompetent, who have repeatedly announced that the large machine she is trying to build must be unsafe, stopping her work to scare her into making an error, and to extract a shot to the jaw whenever a news cutie is watching. She had struggled on issues of safety protocols, research guidelines and brokering agreements among competing nations regarding the use of dark matter. It was a technology that was still evolving quickly. 5 years later, the first dark matter power plants were up and running, supplying clean energy in a quantity so vast there was no room for fossil fuels. Human exploration of the outer solar system was accomplished by means of dark matter propulsion. Applications of controlled dark matter interactions to medicine were instrumental in the development of cancer treatment and genetic therapy. But the weapons programs continued to pose a threat. Due to international treaties and agreements, however, several countries operated clandestine dark matter weapons programs. The technology was too potent and too tempting for some leaders to pass up. Cassandra's first breakthrough came shortly after his 7th birthday, and the first dark matter weapon debuted when he was 7+7. A dark matter device, allowed to be outgoing somewhere in a remote part of Afghanistan, because some terrorist organization had got one and set it off. An explosion with the force of a 50-megaton nuclear bomb. The explosion did not produce any radioactive fallout. It created not a black hole, but a distorted sphere of space-time that lingered for months. The assault prompted the national community to clamp down on dark matter technology. The terrorist group was located and wiped out in weeks, but the message was unmistakable. The technology was too dangerous to go unregulated. Cassandra was in charge of the international response, partnering with law enforcement and intelligence agencies in a hunt for sources of dark matter technology. The network of suppliers and researchers was intricate and international, but over time, they began to track and disrupt criminal operations. The work was grueling and perilous. Cassandra was targeted for assassination by several groups who sought to misappropriate or shut down the dark matter technology. She was confined to live under round-the-clock security, with her movements tracked and curtailed. But she pressed on, a sense of faith that humanity could learn to control and use dark matter technology responsibly propelling her forward. The potential for gains was too high a prize to give up, but so too was the potential for disaster too great to overlook. A decade after Cassandra's first spotlight moment, she was presenting before the United Nations General Assembly a speech that not only had the power to shape human usage of dark matter technology for generations, but would serve as the moment her world comprehensively blended into the human one. When I first learned how to make dark matter interactive, she began, I figured I was just promoting human knowledge. But I did not completely understand that I was giving humanity the power to bend reality itself. The technology we have invented has the power to destroy planets or fuel civilizations. It might make interstellar travel possible or spawn weapons of unimaginable destructiveness. She stopped, scanning the eyes of delegates who had traveled here from every nation on Earth to hear her. We stand at a crossroads. We have the option of utilizing this technology. 2-Qubit and Segal depict an undimensional square lattice with n set at 5. Expand human civilization throughout the galaxy to end all of the diseases that have beset us for centuries. Or we could use it to destroy each other more efficiently than ever before. The speech aired to an audience around the world of billions of people who would bear the consequences of choices made in that moment. Cassandra's words bore the echoes of someone who had glimpsed the both hope and fear of all unrivaled power. We have the power to decide, she finished. We can be the generation that ends our reliance on oil, or we can be the generation that ends up giving mankind the tools for its own destruction. The technology exists. The knowledge cannot be undone. The money and the knowledge are there. The vote was unanimous. The World Dark Matter Accords was signed by the whole world. Institute, the most gigantic network of international cooperation ever seen in the history of mankind. The Accords instituted enforceable restrictions on dark matter arms, compulsory, sharing of helpful applications, and shared regulation of all research. After the signing of the Accords, Cassandra moved out of the public sphere. She continued to teach, mentoring young scientists to ensure that future generations came to understand the potential and moral responsibility entailed by ultimate power. Since then, Rebecca, as the head of the International Dark Matter Regulatory Agency's Environmental Applications Division, would visit her mother in the hospital often. At one, she discovered Cassandra working on roses genetically modified by dark matter-assisted means. "Do you ever regret it?" Rebecca asked. "The discovery. I mean, ever wish you never would have opened it?" Cassandra considered the question carefully. "I regret the weapons. I am sorry for the fear and the instability. But I don't regret the knowing. At some point, humanity was always going to find dark matter interaction. The physics is too basic. The consequences too obvious. At least this way, we had some agency in how it was built." She pointed to the sky, where the lights from the first interstellar colony ship, powered by dark matter, could be seen as a bright star. "Look what we've accomplished. Clean energy for everyone. Medical therapies that were unimaginable a decade ago. We are starting the process of becoming a fully interstellar civilization." Rebecca gave a nod, but looked troubled. "The weapons are still around, however. The technology still exists. What do we do when we meet another species which has dark matter weapons? What happens when, out of necessity, we have to get them out and use them to defend ourselves?" Cassandra smiled sadly. "We'll then deal with that when it arrives. That's what humans are like. We adapt, we learn, we grow. We screw up, but hopefully we also learn how to rise above. The universe is a big, weird, wonderful thing that we do not fully understand. Our task is to ensure that we live long enough to find them." They sat together in the deepening twilight while the stars in the blackening garden showed themselves. Any one of those points of light was a destination for humanity's restless, burgeoning civilization. And the dark matter within those gaps that once was hidden from sight was not hidden anymore. It was now humankind's best friend, and in many ways its most lethal weapon. The future was unknown, but it was also shot through with possibilities. That would have seemed like magic only a generation before. Humanity was learning to program the very bones of reality. What that enlightenment would mean for the future of the machine, transcendence or destruction, was anybody's guess. But for now, in a silent garden, on a small world, orbiting an ordinary star, to epochs of mankind and the heart of an alien stood together at the highest peak of consciousness and of knowledge. The dark matter that lurked around them wasn't dark anymore. It was luminous with the power to remake the cosmos, and in that possibility, with all its perils and ethical ambiguities, was the potential for humankind's most grand adventure, the exploration and transformation of the cosmos itself.